You're so funny.
When do we start designing pipes?
Right. That's a way. That would be a civil engineering class, and I am not qualified.
When do we play? All right, Avery. Joke's over. Not funny. Joke's over, Avery.
Okay.
Joke's over.
So, a couple things. We are talking about, this is a pretty short lesson, so I would like to say to you, please don't hate me. I forgot that there was a half day on Friday. Oh, your class is Thursday. Not Friday. I did say the earliest is Friday, and I forgot about the half day. Because honestly thought, well, this will take us 2 days, and this will not take us 2 days. So, because we've already talked about a lot of the things in this section. So, we know on your purple paper, thank you. On your purple paper, you should have already, I know you know this one, the antiderivative of natural log. Okay. Hang on. So this is going to be trig integrals. There we go. Talking about trig integrals. But also covered in this section are the integral of natural log. No, let's try that again. The integral of 1 over x. How about that? What's the integral of 1 over x? Okay. Natural log absolute value, right? So we know that. We also know the integral of e to the x.
Are the new ones things we should put on our purple sheet? E to the x plus c.
E to the x plus c. Okay. This one should also be on your sheet. I'm sure we wrote it down.
Well, wait. If I have it with my arrows, then I don't need to rewrite it down.
It's your purple sheet.
Okay.
What's the integral of b to the x? It's on your paper. Should be on your paper.
1 over natural log of b times b to the x plus c.
Plus c. 1 over natural log of b times b to the x plus c. Okay, those are already on there. I am not going to, we're not going to do this very much because what is there to do? Really, like if I say to you, okay, what is the integral of 4 times 2 to the x dx? Nope.
It's 4. The top is 4.
Top is 4.
He did say 4.
Did he?
Yeah.
I didn't hear it. Whoops.
So my ears are broken.
4 times natural log 2 times 2 to the x plus c.
I really heard 1.
I also heard 1, so it wasn't just you. Okay. 4 over natural log 2 times 2 to the x plus c. Again, if you're like, oh, that 4 messes me up, that's a multiplied constant. Pull it out in the front, do your antiderivative, and put it back in. Okay. This is really just a memorizer, not super common on the AP test. If it is, it would be in a multiple choice question. Okay, it would be in a multiple choice question where you're going to do the antiderivative of this.
Is it common or present on your test?
I don't remember. That's the honest question.
It's only one thing, Garrett.
I'm sure. Garrett, I would guess that it's on the test.
Okay.
I would guess that it's on there. But it's not going to be anything super complicated. It would be something like this. That's if it's on there. Otherwise, I'll have to go. Oh yeah, no
It
question.
would just be like a thing like, if you know it, you know it. It's going to be like 8 points.
Extra credit.
8 points. Okay, so
I love it.
those are the things you've already talked about. What we need to talk about is the integrals of the trig functions. So I want to show you one of them. You do not need to know how to do this, but I want you to see where they come from. We're going to do one of the easy ones. There are 2 we already know, 2 that are easy, and 2 that are ridiculously difficult. Okay, so we already know. What's the integral of sine of x? Oh, wow. Shh. The integral of sine x dx is what? Negative cosine. Okay, plus c.
So this is purple sheet.
You should already have it.
Yes, this one.
Yep.
Like the new
Okay.
ones.
What's the integral of cosine x, which we already know? sine x plus c. Okay. So let me show you how they get, nope, let's do it this way. Let me give you the integral of tangent. Tangent of x dx. So the integral of tangent is negative natural log absolute value of cosine x plus c. Yeah, it's actually very doable. This is the one that's doable, and I'll show you how they get it.
Well, you do like, you make it in terms of sine and cosine. Oh, yeah, that makes sense.
Okay, so cotangent also not terrible. So cotangent of x dx is equal to the natural log of sine x plus c. It's just not negative. The next two are ridiculously difficult. If you want to know how to do them, feel free to read the textbook. Okay, so the integral of secant secant x dx is natural log absolute value secant x plus tangent x plus c. Like, they're not difficult in the writing of them, but they're difficult in the coming up with them. Right? The integral of cosecant x dx is negative natural log absolute value cosecant x plus cotangent x plus c. Now, I'll be real clear with you. I do not have secant and cosecant memorized. Okay? Would I recommend you spending time on that? No. Should you probably know the antiderivative of tangent and cotangent? Yes. But also the good news about that is it's very doable to find it if you don't remember it. Okay? So, good news. That's good news. So, let me show you how they got the integral of tangent. You guys we're talking about it. So, tangent, we know, this doesn't help me. Tangent, whoop-de-shmoo, who cares? Like, there's no antiderivative of that. But if you write it as sine x over cosine x, then you can get somewhere. Okay? Because you can use u substitution with this. What would your u be? Which one? Cosine x, right. Because what's the derivative of cosine? Sine. Also, if you're not sure, it's the one on the bottom, right? It's the one on the bottom. So du would be sine x, negative sine x dx, right? Thank you. Negative sine x dx. So then you just do your u substitution, right? This needs to be a negative, right? This needs to be a positive, so this has to be a negative. So then substitute, and you end up with a negative because they're supposed to be a negative. And then you've got a 1 over u du.
Will it work if you try to use the sine x as your u?
Watch what happens. So if you make, let's do this over here. Don't put in your notes. We'll see what's an experiment. So if u is sine x, what is...
Negative cosine.
Nope, it's cosine. The problem is that this is 1 over cosine. It's not cosine. Right? Do you understand what I'm saying? This cosine is on the bottom. This is really sine x times 1 over cosine x dx. This cannot directly substitute because this cosine is on the bottom. So that's a no-go.
Can't do it 1 over du. That's cheating.
1 over du then puts your du on the bottom, which you can't have. So yeah, it doesn't work.
Because it would just make it
A very nasty bunch of reciprocals. Doesn't work. So anyways, this is negative. What's the antiderivative here? What's the antiderivative of 1 over u? There's where the natural log and the absolute value come from, up here, and then you put your u back, and it's cosine x. So if you're on a test and you're like, I don't remember the derivatives of cosine and you know what? I don't know cosecant and cotangent, but I also don't know tangent and cotangent. If I had to do them, I'd do them this way. I just turn them into sines and cosines and use substitution.
Is there a dog rule for the secant and cosecant that
No.
would? So then how do they get that?
You can read the book. I'm 100% serious. I'll tell you what page it's on. I don't want to do it. It's not worth the time. It is on page 351, example 9. Okay? It's fabulous. I'm sure you will enjoy perusing it. Okay? So let me say, yuck. I don't really want to do very many of these either because I don't like them. So
They're just boring.
they're just boring, pretty much. The most you're going to get with one of these is maybe it's an inside function and you have to use some use substitution with it. So let's do this one. So let's say you're going to do the integral of, nope, that's dumb too. Nope, not doing it.
So when you say you said we don't need to memorize the secant stuff.
I would
Does
not.
that mean it's not on the test?
My test? No.
Okay.
And I will double check and make sure I'm not lying to you, but I would never do that. Like that's hypocritical in my personal opinion because I don't have it memorized. Okay. So I guess here's what I'd like you to do. While I figure out what I want you to do for your homework, you see if you can use the same situation to verify the cotangent one. Okay, so just see if you break it up, if you can get u substitution to give you that antiderivative of cotangent.
You flip the sign because I just know I already know it's all I need is your antiderivative. Here, you want to try and solve the ones that are evil?
No.
Here, look at it in the book right now. 351 example 9. Where's you? So why did they add that in? Yeah, why did they add secant x plus tan x over secant x plus tan x? Stupid. I hate math. It's just multiplying by 1, but then so you can cancel. This is with the dog.
That is, but not what. Oh, yeah, I'm sure. Eventually there's a dog.
Is the first thing they do, they multiply it by 1 technically.
One technically.
And then that gives them.
It's not a dog. It is not a dog that it's using.
Okay, sorry. Let me look at this again.
Look at their use substitution.
Yeah, that's, I'm never doing that.
No.
You would have to memorize that to know that.
Correct. Correct. It's stupid. Personal opinion.
It makes sense as far as like why they do it, but like
That's how they originally got the equation, but once you get the equation, you should never do it again, ever.
Correct.
yeah, it's not something you'll intuitively think of. Like,
No.
oh, I need to combine tangent. Oh,
Right.
I need to put secant x plus tangent x over secant x plus tangent x and multiply it by what I had originally. Oh, obviously.
Whoa. So that's not.
Is it pouring right now?
Mhm.
Very soothing.
Mm-hmm.
Garrett, do you wanna go out in the sun or in the rain like worms?
And wriggle around.
Weirdos. Okay. You should be able to get cotangent to work just fine. So cotangent would be the integral of cosine over sine. Right?
Yeah.
And u would be what?
Sine.
Sine x. And then du would be straight up cosine. And that's an even easier substitution because there's no negatives. That's why this guy does not have a negative in there. Okay? So if you choose not to memorize these, this is not a critical statement. It's not a passive-aggressive statement either. If you choose not to memorize these, just be able to do this. Know that they come from the sine-cosine definition of it, and you do use substitution. Again, I do not have them memorized. I would just do this. So here's what I would like from you. Like, they're so unimportant that there are very few of these in the book, which is lovely for you. I want you to do, it's page 353.
Is this our homework?
Yep.
That's what you were doing. Okay.
Yep. That's okay.
Miles Dewey? More like
I asked you to done it.
Miles
Dude.
Dewey.
What if we were moles? Like, straight up.
Ooh, that'd be tough.
Stargates moles.
Thank you, Miles.
Miles, did anyone ever told you before that you kind of look like Miles Dewey?
Dude, that's like the brother of Reed.
You are the brother of Redo.
I already realized.
Douglas can only have one more sheet.
Ooh, thank you.
Bruh. There aren't even that many problems.
Nope, they're not. You guys have a decent amount of time to do this. I will tell you to be wise in the way that don't assume that these are all use substitution. That's what I want to say. Some of them you should simplify first. Okay?
Garrett, there's so many of them that you have to do that I need to do that I'm thinking I might have to do that. No, I'm still gonna be here. I'm not gonna take away my book. I'm just saying that there's no point